Welcome to the CompTIA Network Plus N10 This is Chapter 4, Ethernet Standards. So for today's objective, we'll look at 1.2, explain the characteristics of network topologies and network types, and 1.3, summarize the types of cables and connectors and explain which is the appropriate type for a solution. So we've already talked about 10 base T and we're moving on. So the next one is 100 base T. Guess what 100 stands for? Well, 100 stands for is 100 megabits per second. It is baseband and it works over distances of 100 meters. No more than 1024 hosts on each hub or switch. It uses a variety of different topologies. From stars and meshes and buses, and you need at least Cat5 to run it. So at this time, we had compatibility issues. What if you had a 10 base T NIC and you had a router or a switch that's 100 base T? Well, they need to be able to negotiate. So this is called, essentially, negotiation. So figure out what kind of bandwidth you need, what throughput, and now they talk, hey, I'm this, hey, you're that. Then they'll agree to connect on 100 base T since they both can support 100. So it's pretty cool. Compatibility was not that much of an issue. Okay, moving on. So what about the fiber aspect? Fiber is quite important, and we're going to talk about fiber a lot today. So yes, there is 100 base FX. It works over 100 megabits per second, is also baseband, but look at this, you get 2 kilometers between the switch and the host. So that's pretty long, much longer than the other standard that we just saw. And it uses multi-mode, can use one of the older connectors, which is straight tip or subscriber connector where you have to twist it on. So in the early days, those were the popular connectors. KSX is a short distance that is LED based, and it runs at 850 nanometers. So we're going to talk about different nanometers and the wavelengths that they use for fiber. That's quite important. And if you're curious, you can look at your device manager and see what kind of Ethernet standards you're using on your network adapters. It'll tell you. So this one says fast Ethernet. Fast Ethernet is 100 megabits per second. That is kind of another name that the industry had for it. Okay, moving on. So, network interfaces should be half duplex or full duplex. Which one are you using? What kind of speed do you have on your network device? Well, if you go into devices like we just saw and you look at advanced, you can see if you have auto negotiation on, which we just spoke about in the last few slides. So it can figure out what kind of speed you need and get you connected. Okay, moving on to 1000 base. So now we're at 1000 base and fiber is taking over. So this is also called gigabit. This is a pretty standardized around the office everywhere. You can see these type of connectors. SX is for multi-mode, but it doesn't go a very long distance. Okay, and opposite, LX is for single mode. It's only one way, but it travels much further. So depending on the needs of your organization, do you need distance or do you need speed? You would pick one of these. Also, on the right here, we can easily switch between these technologies and convert from the media. So you can go from single mode to unshielded twisted pair. You can go multi-mode to untwisted pair. You can go fiber coaxial, single mode fiber to multi-mode fiber. So there's a lot of different combinations and setups for fiber. Okay, moving on. We're going to look at what's called SONET. Now, before fiber was being standardized, we already had SONET, which stands for Synchronous Optical Network, and it was already in place for wide area networking, so you can send signals over the public internet. However, IEEE decided to build on top of this to make a standard. So you can see SW for the SONET over WAN, or if you're just inside your local area network, you can use SR. So take a look that these end with R and these end with W. Remember that for your test, it'll be useful. So we can take a look at the different standards here. 10 base that works in multi-mode, same wavelength. You can see the different signals that we just talked about, like SONET and LAN, and then the signal length, quite short. Okay, a lot of people will probably choose down here in single mode. You can get much further distance of 10 kilometers, but it's a different wavelength as well. And then down here, you can get up to 40 kilometers, which is very, very long in single mode. And again, different wavelength and different topologies. Okay, what about copper? What if you need to convert your signal to copper inside a network? Well, yep, it's possible. You can use these different multiplexing devices. These are called transceivers. Some of them are bidirectional transceivers, so you can receive at a certain wavelength and then send at a certain wavelength, which should increase your throughput and make it much faster. Okay, and for the last slide, we're going to look at the different backbones. So what is a backbone exactly? That is just what connects a different segment of your network and routes it to the core switch, or we call them backbones. So you can see these different network segments, and even these servers down here have their own switch, and then it routes to the backbone, the core, and it all goes to the same place essentially. We were talking about bidirectional receivers in the last slide. Here's an example of what it looks like. As long as the receiving and the sending have two bidirectionals, then you can send and receive at different wavelengths. You can take advantage of the different topologies that go further at different distances, and you can resolve problems of distance much better and get better throughput. Okay, so we're at the pop quiz here. I'm going to read these questions. Think about them. How does a 10 base T NIC talk to a 100 base T router? Okay, 2. What is SONET? 3. What are the advantages of bidirectional transceivers? How does a 10 base T NIC talk to a 100 base T router? Well, we talked about what's called negotiation. They're going to say, hey, I'm on 10, hey, I'm on 100, okay, we can both use, they decide here 100 because they both support 100, right? So if they both support it, they will negotiate and create the connection. Okay, what is SONET? We were talking about SONET earlier. SONET was around before fiber infrastructure was. So SONET is the synchronous optical network, and the IEEE built upon this for WAN or public internet connections. Okay, what are the advantages of bidirectional transceivers? We were talking about that. So you can have a single mode fiber on one wavelength and another single mode fiber on another wavelength, and they both can send and receive to the same point. So that is the advantage, that you can use more than one signal in different wavelength. For example, 1310 nanometers, and maybe this one is 1550 nanometers. You would get the advantages of those single modes that work at further distances. Thank you for watching.